Tianlai.China bridges the Ming Dynasty's material civilization and contemporary data science through digital humanities, constructing a genetic map of their connections. This is the world's first systematic digital initiative dedicated to studying the Ming Dynasty's canonical texts on art appreciation and collection, and represents a transcendent dialogue spanning 5 centuries. First, navigate to the first section of the website. What is Tianlai.China? Tianlai.China is a digital humanities project centered on the illustrated catalog of famous porcelains through the dynasties, Lidai Minkitus, compiled by Xiang Yuanbian, a renowned Ming Dynasty connoisseur and collector. We conduct multi-dimensional visual analysis of 83 rare porcelains documented in the canon, systematically transforming the traditional authentication system into visualizable, interactive, and quantifiable data language for the first time. Why do we create Tianlai.China? For centuries, art historical research has faced 3 enduring challenges. The original manuscript is long lost, its ceramics, as crucial carriers of traditional Chinese culture, have mostly vanished, leaving invaluable clues for studying ancient material civilization. Origins chapter. Begin with an introduction to the website, then scroll down to explore the historical context of Xiang Yuanbian and the Xiang family. In the mid to late Ming Dynasty, Xiang Yuanbian hailed as the preeminent collector of Jiangnan in the late Ming period. The illustrated catalog of famous porcelains through the dynasties pioneered the systematic documentation of renowned ceramics through an innovative integration of illustrations and annotations. Next, based on historical records and classical references, we have reconstructed Xiang Yuanbian's 5 key connoisseurship scenarios into a gamified immersive experience, allowing users to step into the Ming Dynasty's art appreciation practices through interactive storytelling. We will transport you back to the Ming Dynasty's Wanli era, immersing you in the bustling cityscape of Jiaxing Prefecture, where beneath the upturned eaves of Tianlai.China, you'll unravel a 400-year-old sealed ceramic epic. The virtual environment of Tianlai.China reconstructs the connoisseurship scene through spatial storytelling, from merchant negotiations at the grain tribute ship docks to motif identification in antique shops, immersing users in the dynamic networks of Ming Dynasty art circulation. Every detail embodies the dynamic interplay between Ming Dynasty commerce and culture. We employ knowledge graph technology to interlink figures, artifacts, and texts, constructing a visualizable network of connoisseurship and collection dynamics. Transform historical scenes into interactive living archives, where the past becomes a dynamic, user-driven exploration. Next, navigate to the second section of the website, Analysis chapter. This section reveals the spatio-temporal patterns and physical properties of ceramics through multidimensional, interactive, and dynamic data visualization. First, scroll through the interactive porcelain overview to explore the basic information of the 83 ceramics. Click to explore multi-dimensional details of each porcelain and access original texts from the illustrated catalog of famous porcelains through the dynasties. Next, the Sankey diagram visualization, inspired by fluid dynamics, reveals multi-dimensional relationships among ceramics, dynasties, kilns, and vessel forms. Users can interactively drag, click, or scroll through the chart to explore dynamic data flows. The bubble map visualization utilizes geographical distribution and bubble size to visually illustrate the rise and decline patterns of kilns across different historical periods. The tree map visualization, through nested rectangular hierarchies, reveals the evolutionary logic linking spatio-temporal distribution and decorative craftsmanship of ceramics. Next, the physical properties and design patterns of the 83 porcelain pieces are explored. We selected parameters such as height-to-width ratio and volume class, and radar charts comparing the dimensional proportionality characteristics of 23 different vessel types of 83 porcelains. For the color analysis of the porcelain, firstly, we extracted the color swatches of each piece of porcelain and created a visual overview map. The ring and dot distribution diagrams show the color, categories and percentages of the 83 pieces that make up the visual chromatographic library of the porcelain. Next, move on to the third section of the site, a micro-analysis of the uniqueness of 83 pieces of porcelain in Xiang Yuanbian's collection, using an original quantitative model of porcelain uniqueness. We categorized the porcelains according to their vessel type and extracted the profile shapes of 83 pieces, from which we discovered their differences and uniqueness from conventional porcelains. Silhouettes of 83 pieces of porcelain unfold on the screen, and clicking on the outline of any porcelain shape zooms in and displays subtle particle animation. The profile curves of the porcelain in Xiang Yuanbian's collection differ dramatically from the mass-produced porcelain of his contemporaries' kilns. It is these lines that break free of paradigmatic constraints that lead us to ask, how can we measure the genes of uniqueness of artifacts with data? The core of the micro-exploration chapter is the first porcelain uniqueness quantification model, which aims to scientifically quantify the value of its uniqueness from ordinary porcelain through multidimensional parametric analysis. The model builds a set of objective evaluation system from the 5 dimensions of shape and modeling, decoration, glaze, craftsmanship, and historical background. Below is a radar chart of the 5-dimensional standardized scores, quantifying the uniqueness of the 83 pieces of porcelain. Users can click to see the distribution of the 5-dimensional uniqueness scores for any piece of porcelain. Below is a line graph of the composite scores. On the left, the 83 porcelain uniqueness scores are ranked according to their composite scores from highest to lowest, allowing the user to visualize the top and bottom of the high uniqueness scores. The color of the dots varies according to the overall score, and the fluctuating curve reveals the peaks of preference in Xiang's collection. The following is a list of the top 10 porcelain wares with high uniqueness, dynamically sorted to show the top 10 porcelain wares with uniqueness, and click on them to view the details of the porcelain wares and build a data-based cultural relics ranking. You can also view 360-degree rotating animations of 3D restored models of the top 3 porcelain pieces with high uniqueness. Next, move on to the 4th section of the site. In the chapter of Tasting Rhyme, through the visual analysis of Xiang Yuanbian's personal evaluation and aesthetic preference map, we decode Xiang Yuanbian's personal aesthetic preference for collecting and explore the deep connection between Xiang Yuanbian's personal subjective preference and objective data. In the chapter of Tasting Rhyme, through the visual analysis of Xiang Yuanbian, this article, the commentary of 83 porcelain pieces in the atlas, is subjected to sentiment analysis and keyword extraction through natural language processing, NLP technology, and the high-frequency words in the word cloud map are the mapping of the spirit of the literati. In the following, the quantitative rating of the rubrics is derived based on the classification of Xiang Yuanbian's rubrics sentiment preferences, and the keywords of Xiang Yuanbian's evaluation are visualized for sentiment analysis. Evaluation quantitative ratings in 3 categories: very high, 33 cases, high, 29 cases, and medium, 21 cases. Users can click through to see the porcelain covered in each rating category and details. Next, the deeper correlation between Xiang Yuanbian's personal subjective preference and the multi-dimensional features of porcelain is explored. The dotted line visualization charts show the relationship between Xiang Yuanbian's evaluation and the decoration and function of the porcelain. The Sankey diagram and the chord diagram show the correlation between Xiang Yuanbian's personal evaluation and the kill and porcelain decoration, respectively. Next, the deeper correlation between Xiang Yuanbian's personal subjective below is a list of 30 pieces of porcelain that have been rated as very high according to Xiang Yuanbian's rating preference, and users can click to view the detailed information and original rating of each piece of porcelain. In the end, the subjective-objective dialogue is constructed so that the unique quantitative data and the subjective preference of Xiang Yuanbian can collide in the correlation network, verifying the practical logic of carrying the way with the tool. Here, data and commentary intertwine, subjectivity and objectivity resonate, reconstructing the aesthetic genetic map of a museum gentleman. Tianlai.China is not only a digital rebirth, but also a paradigm breakthrough in interdisciplinary research. Tianlai.China proves that data visualization is not only a technical tool, but also an intersection of cultural practice and ethical responsibility. When viewers look at data visualization charts and models of lost porcelain, they are also participating in a cultural restoration, restoring porcelain-making skills destroyed by the Industrial Revolution and local knowledge systems lost in the process of globalization.